We've all seen it, right? That promise of 5 nines uptime for critical internet services. 99.999%. I mean, it sounds just about perfect, but what if I told you that number is actually hiding a crucial part of the story? A hidden risk that could bring your entire service down when you can least afford it. Okay, so here's how we're gonna break this all down. First, we'll dive into the uptime promise itself. Then, we're gonna pull back the curtain on a pretty big flaw in the nines. After that, we'll check out a much smarter way of doing things called networking with an intent, see how it actually figures out the real risk, and wrap up with what this all means for, well, a much more honest internet. So, when a business goes out to buy a big, high-speed internet connection, they're not just buying speed. What they're really buying is a promise of reliability. And that promise, it almost always boils down to one very, very specific number. Yep, that one, 99.999%. You've probably heard it called 5 nines. It's become the gold standard, you know? It's the ultimate promise of dependability. Now, this promise isn't just a handshake deal. It gets formalized in something called a service level agreement, or an SLA. That's the actual contract that guarantees your uptime. But here's the catch, and it's a big one that most people miss. These contracts are almost always for a short period of time, like just 1 year. And that limited time frame, that's exactly where this whole perfect promise begins to fall apart. So where's the flaw? Well, it's actually hiding in the math. That famous percentage is based on a long-term average, but your contract is just a short-term snapshot. And trust me, those two things are not the same at all. So you really have to ask yourself, what does 99.99% availability actually mean for your specific 1-year contract? As it turns out, the statistical promise you see on paper and what you experience in the real world can be miles apart. Okay, so here's the core of the problem. We're sold this long-term, almost theoretical number that engineers call asymptotic availability. It's the average over like an infinite amount of time. But we live in the here and now, in the short-term reality of our actual contract period. That's called interval availability. And unlike that smooth, predictable average, our reality is random. It can fluctuate wildly. Think about it like this. A city's average temperature for the whole year might be a pleasant 70 degrees, but that average completely hides the freezing winters and the scorching summers. That long-term average means absolutely nothing when you're booking a 1-week vacation in the middle of January, right? This huge disconnect gives rise to a really important concept that network engineers call non-fulfillment risk, or NFR, and it's exactly what it sounds like. It's the hidden probability that no matter what the long-term average says, your provider is going to fail to meet their uptime promise during your contract. And this is not some tiny academic risk we're talking about. The data is pretty shocking. For a service promising 99.9% availability, the actual risk of failing to meet that promise in just 1 year can be as high as 20%. That's a 1 in 5 chance that your so-called guaranteed service will fail you. So if the old way of measuring reliability is so broken, how do we fix it? Well, the answer is to stop building dumb networks and start building smart ones. Networks that are automated and, maybe most importantly, brutally honest about the real risks. See, the old way involved engineers sitting there manually typing in thousands of complex commands. The new way is about simply telling the network your goal or your intent. You just say, hey, I need a connection from point A to point B with this much speed and this level of reliability. And the network itself actually figures out how to make it all happen. This whole approach is called intent-based networking, or IBN for short, and it is a complete game changer because it automates away all that manual complexity. It lets us build networks based on the business outcomes we want, not the thousands of low-level commands we used to have to type. So a user just states their intent, and this whole system of intelligent components just kicks into gear. It translates that simple goal into a real functioning service, all while making sure it meets all the requirements. It's kind of like having a super smart network manager built right into the system. 2 key pieces of tech make this possible. First, something called a network digital twin, which is a perfect live simulation of the entire network. And second, the failure management module. You can think of this part as the brains of the operation. It uses that digital twin to constantly run what-if scenarios, calculating not just theoretical uptime, but the actual real-world risk of failure. Okay, so that's all the cool tech working in the background. But what does this actually look like to a user? This is where all that complex technology gets transformed into a simple, powerful tool that makes that hidden risk completely visible. So this is pretty much how a user would interact with a system like this. It's basically a simple chatbot. You just select your locations, the data rate you want, and the availability you need. In this case, 99.98%. You're just stating your intent. And here it is. This is the magic moment. The system comes back not just with a price, but with this critical piece of information. Risk of not fulfilling the SLA, 0.320%. For the very first time, that hidden risk is dragged right out into the open. This one number changes absolutely everything. You're no longer buying some vague promise based on a flawed average. You are getting a concrete, actionable number that quantifies your actual risk and that allows you to make a truly informed business decision. This fundamental change, this shift from blind trust in averages to transparent, calculated risk, this is what a more honest internet looks like. It's a shift from just making promises to providing actual proof. This really shows you the gap between the promise and the reality. For a provider to truly guarantee that your risk of failure is less than 5%, their internal, real-world performance has to be way better than what they advertise. To promise you 99.915% availability with real confidence, their long-term average might need to be all the way up at 99.987%. So the big takeaway here is this. We finally have the technology to build systems that are not only reliable, but are also honest about their own limitations. We can finally move beyond just hope and flawed averages and into an era of real transparency and mathematically proven risk. And that really leaves us with a final thought. As this technology becomes more common, the very definition of reliability is about to change forever. So, would you rather choose a service that promises 99.99% uptime or one that guarantees a little less, say 99.95%, but can prove to you, mathematically, that its risk is near zero? The answer to that question could end up reshaping the entire digital world.